Welcome back to another video. What's up guys, software engineers. So today's video is about solving linked list, reversing linked list. So linked list is a data structure where it has it could be multiple nodes linked together each other like this, and maybe like head is pointed to one. This is a node, right? And the node itself has value attribute as well as next, usually like next field. And next field is pointed to 2, right? This is the reference to a next node. And then maybe node 2 is pointed to null, meaning that this is a tail node. So what we're going to tackle today, this question, is how to reverse linked list. So from here, we call this reverse, and what we want, like product of calling this function, is like this. So basically we reverse the order of linked list. So we're going to tackle this one today, and first we want to start with corner case and some assumptions. So when we were given like a task like this, first thing to think about is assumption. Like for example, let's say we define the API reverse, right? And then we pass node head. What we want to think about first is, can this head be null, or can this, what is the corner case, conditions? So let's assume that the corner case would be head points to null, right? Another case is linked list consists of just one node, so points to 1, and then 1, like a node containing value 1 points to nothing, so null. So this case is when node, like linked list size is just 1. This linked list size is 2, is 0. And then maybe standard case is like 1, 2, and then 3, and then null, right? So let's handle these cases. Whenever head is null, or if head's next is null, meaning these two cases, then we can say that we can return head itself, because reverse of linked size of size 1 is actually itself, so we can just return head. When it's null, then we can just return head, right? So these are the first case. We can say if head is equal to null, or head dot next is equal to null, then return head. That's easy. So we just covered these two cases, and then we're going to move on to a normal case where linked list consists of one or more than one, equal to or more than or equal to one node. In this case, what we want to do, we have several ways to do this. One way is the iterative way, using pointer manipulation. Other one is recursive, basically calling making a recursive calls, basically adding a next function call on top of the stack, so it will use space up to n, where n is the size of linked list. So what we're going to do is to do the recursive one, because the recursive one is a little more complex and it requires a little bit of wrapping your head around. So let's get into it. So recursive one, you can think about this as a top-down approach, bottom-up approach. So we can think about head down, top down, and then bottom up. What I mean by top down and bottom up is coming from the bottom or tail, and then going back to the head. So this is bottom up approach. So what we want to do is to define the base case, which is this one. So this is base case. So we're going to say when the head is null, or when head heads next is null, then we hit the base case because we don't need to recurse subproblems anymore because we don't have any more subproblem. So start from here, make a recursive call to heads next, which is 2, 3 null, right? And then when we get to 2, we're gonna make a recursive call to the rest of the next node, and then do that, and basically breaking down. And then at the base case, it's gonna return null, like a head itself, not the null but head itself. Otherwise, when we are here, head is here. What we want to do is basically reverse this angle here, going back. So here, so make a recursive call, and then node n reverse. So basically, this is going to make a recursive call, and the last call will be here. So when head is 3, right, and it will make another recursive call, and the head is going to be null, right, because 3's next is null, and then that's going to make a recursive call here and then return head, which is null, right? So right now, it will return, hold on, yeah, so it will return null here, and that's fine. And then what we're going to do is to have heads next point back to 2, right? No, actually, heads next is null. Heads next. So yeah, so when head is pointing to 2, right, and the head next is actually 3. 3 is passed as a head. 3's next is null, so return 3. It will return 3. So here is actually 3. And then head is pointed to 2. So what we're going to do is have 3's next pointed to head itself. So what we do here is heads next point back to head itself. So this is here. 2's next, which is 3, points to 2 itself. So we just cut this link here and bring it back, point it back to 2 itself, right? And then after that, basically, we want to cut heads. We want to say, after this, we want to return this node n, which is actually 3, because 3 is going to be a new head. So at the end, we are going to return n. Or like we could say root, like head, but it is n. So that's the end. So I just want to make sure that I'm not missing anything here. So from first, when the case, easy case is 1, 2. In this case, 1, 2. Last recursive call will be here when 1. No, actually, I was wrong. What I need to do is, so last one will be this one, last node. So the bottom up, so this is going to be head. So head next, right? I'm a little bit getting confused, which is okay. Get to the last node of the linked list here, and then it won't be here. Sorry about that. So get to the second last linked list. So head is here now, and then head next is 2, right? And the next recursive call, head is 2. Head dot next is null. Okay, so return 2 itself back, right? So this is actually 2 return, and head is 1 now in the first call. And what we want to do is heads next next, which is this arrow. Head next next, point back to head itself. So here, I know this is confusing. That's why we are doing this, because the recursive one is a little more tricky. So head is 2. 2.next is 2. That's what we want. Head.next is head. All right. So head.2.next is 1. It's actually 1. It is okay to make mistakes like this when you are doing a whiteboard coding interview, because this is like just you are talking out loud, thinking out loud. You're in a process, and it is natural, right? So 1.next, which is 2. 2.next is now right now, but we want to have 2 point back to 1. So 2's next is 1. See? So head.next is 1, head itself, which is good. And then, so that's good. We just took care of this one. Cut this one and then reversed right now. What you want to do is to have this one, like heads next, point back to previous one as well. Or like set this to null actually. So what we want to do is head.next is null. And so we just cut it here and then set it to null. So now it's actually pointing to null. Null. And then we are returning n, which is 2, as a new head. So head is pointing to new head as a 2. So we just have head pointed to 2 point to 1, 1 point to null. So this is the recursive reverse public let's say node. And yeah, so we just implemented reverse linked list function in recursive way, and let's go through a simple test case where head is null, then return head itself. That's it, it'll return, so it's good, it's null. If it's 1, head.next is null, which is this case, then return 1 itself. That's good. And when it's 1, 2, 3, right? So 1, head is 1, 1 is not now, 1.next is 2, which is not now, so go here, make recursive call, pass 2, right? And the 2.next is 3, so it's not now yet, which is good. So now pass 3, right? Pass 3. 3 comes here, 3.next is null, so return head, which is 3 now. And then this is the base case, we hit here, so we return. We are not gonna go down here to make another recursive call for sub-problems codes. 3's next is null, right? And then it'll return back to previous calls. So 3 is returned here, and then now it's a recursive, like previous recursive call stack now. So now head is 2, and then 3 is returned now, and then head is 2. So 2.next next 2.next is 3, and then 3.next is right now pointing to null, but it'll point back to 2. So this is, remember this a reversing angle here. So 2.next is pointing back to 2, and then 2.next used to point to 3, but it'll point back to null right now, and then return 3, and then let's go back to previous recursive call stack. Now head is 1, and then so here we passed 2, right? And then it returned 3 as a new head. But we are not gonna do anything with 3 because we're gonna just return 3 in previous calls. But what we have here now is head is 1, 1.next, right? 1.next is pointed to 2. So 2's next is now pointing back to 1. This is where we're going to update. Previously, we set 2's next to null, but now we are from 1. 1 dot next is 2. 2's next is now pointing back to 1. So updating, reassigning value. And then head next, which is 1's next, we are cutting here, and then finally setting it to null, right? And then return 3. So now we just reverse this to 3, 2, 1, null. And then we just return this one as a new head in this reverse. So that's it, guys. This is a recursive way of reversing linked list. It's pretty complicated. When I remember like when I first learned about this, it took me like maybe 5-10 times. I mean, like over the course of like few years to really understand things. And the trick here is to think about call stack here, right? When you make recursive calls, first one is reverse with 1, right? This is a call stack. And then next time we're gonna pass head.next, which is 2. So we're gonna call reverse 2, right? And then we want to think about the base case, bottom-up approach. Bottom-up. So we want to think about when is a base, like until when we want to make recursive calls. In this case, 3. Right, because 3 at this point, 3.next is null. So at this point, it'll return. So it's popping, like pushing, 2, 1, 2, 3. And then 3 at the point, it'll return 3. So now stack is popped up, pop. So this one is gone. And then now go back to 2. And then 2 and is actually 3, right? Because it got returned from here. And then do operation, blah, blah, blah. And then eventually it'll return 3. So return 3 back to previous one. So now another subproblem recursive call is returned. It'll get out of the stack. And then lastly, it'll come back to the top. So that's why how we think about is making recursive call, get to the last node of the linked list, right? And then pushing, and then popping. And then lastly, we're going to hit the first node, which is the top. That's why it's called bottom up, because we visit bottom first and then come back to the top later. And then lastly, when recursive call 1 is called, and it's still 3, and then gonna do that like basically one's next is 1, and then 1.next is null. So we just did that here, this part. And then finally return 3 as a new head. So we just did, in this short 10-15 minutes, we've written a recursive call of reversing function. I'll test it. Testing is pretty important, as well as a 100 corner case. And a corner case is usually like really small numbers. Like parameter tends to be usually really small. It could be, null, 1, 2, or like even number, odd number. With that said, next video I'm gonna do iterative way of reversing linked list. So stay tuned. It'll be fun to solve this kind of problem. This is really important, super foundational, basic reverse function, because it requires pointer manipulation, thinking in recursion, thinking in bottom up. Recursion always bottom up. And recursion is going to come up when you do tree or binary search tree, binary tree problems, like getting a max height of subtree, or thinking about lowest common ancestor binary search tree and a binary tree, which is pretty complicated. I would say it's pretty difficult to do a lowest common ancestor binary tree. It took me a while to really understand bottom-up approach. So we're going to visit that, but this is the foundation. So if you still have some trouble understanding, watch back this video to really understand the concept. Code doesn't really matter. What you need to understand is this concept. I can draw out, map out diagrams so that you have this visualization of this whole nature of the problem. And then really the key is bottom up. With that said, I'll see you guys in the next video. iterative way to reverse linked list. If you like this video or if you found this video helpful, give it a thumbs up because that'll be my motivation to create another videos for coding technical questions. And this YouTube channel is going to be focusing on learning technical coding interview questions together. So with that said, thank you guys for watching. I'll see you guys in the next video. Bye bye.